We're kind of switching gears for a second here, though. Take your brain back to algebra type of stuff. So the idea we're looking at here is how do we find an average of things? So here, there's just a list of numbers, 8, 5, 1, -1, 6, -3. How would you find the average of that? You don't have to actually like come up with the number right now, but just how would you do it? Yeah, let's see Brandon there. Yeah, add them together, then divide by how many numbers you added. Perfect. That's exactly what you would do. So you would add them together, numbers together, and divide by the number of numbers. Okay. So yeah, that's good. You would add them together and divide by the number of numbers. You end up getting 8/3 for this, but that doesn't particularly matter. What we're more interested in is how we're going to translate this to a function in general, because a list of numbers is not the same thing as a function, right? We can get a list of numbers based on a function, but it's not the same thing. All right, so translating this to a function where we say adding the numbers together, that's taking a total of something. And in function terms, we're going to look at the total or net area between the function and the x-axis, which we've kind of seen in this section means we're going to take an integral. Okay. You can also kind of think of this being as adding is the sum of numbers. And we know integrals also refer to a summation process, a Riemann sum. Okay. So we're going to take an integral, that's like the adding things up part, and then to divide by the number of numbers, here, since it's like a continuous strip that we're looking at, some sort of interval, we're going to divide by the length of the interval. Okay, so that same idea we can just extend to a continuous function. Add things together, take the integral, divide by the number of numbers, divide by the length of the interval that you're looking at. So when we're doing the average value of a function, f of x, on the interval from a to b, the formula we're going to use is something like this. There's different notations for how to write average value of f. I think the one the book uses is like this, AVF. But I've also seen it like f AVG, that way it's like function average. You can use whichever one is most comfortable for you. So that's just notation for average value of f. And then we are going to take the integral of that function on our interval a to b, f of x dx. And then we're going to divide by the length of our interval. So divide that by b minus a. So this is here, and this is down here. Okay. So that is the average value formula. You could also write that, if you don't like a huge fraction, you could say 1 over b minus a times the integral, a to b f of x dx. Algebraically, that's totally the same thing. So I guess I'll put like a little dashed line here separating your options. Okay. So yeah, that's how we're going to find average value. And let's do that here. All right. So in problem 3, we are going to find the average value of f of x equals 4 minus 2x on the interval from 0 to 6. So using our handy dandy formula there, that would say the average value of f equals the integral from 0 to 6, because there's our a to b there, of f of x, 4 minus 2x dx. And then we're going to divide by the length of our interval. So we take b minus a, 6 minus 0. And conveniently for this one, you might notice that that integral is the one we just did. All right, integral from 0 to 6 of 4 minus 2x dx. Ta-da! Magic integral complete. Okay, so that is negative 12. We just did that previous problem. Okay, and then length of our interval is 6, of course. And so we'd get an average value of negative 2. Okay, but it's worth looking at what this is actually doing graphically. So if we look at a graph of our function, which I know we graphed for the net area stuff, but I'll make a fresh graph down here. All right, so I don't like this big line in the middle of the page. Oh well, all right. I'm gonna use it as the x-axis. There we go. All right, so yeah, we had our line with the intercept of 4. Okay, 2, 3, 4, 5, 6, 7, 8, negative 4, positive 4. Okay, 1, 2, 3, 4, 5, 6. Okay. So let me make a line there. Okay. I wish this was a faster process. Sorry. Okay. There we go. Okay, so there's our function. And yeah, we're focusing still on that interval from x equals 0 to x equals 6 right there. So what this is asking for, the average value of f, it's saying like, okay, average of f means what is the average y value on this interval? Okay, that's literally what it's asking for. So when we find that the average value of f is negative 2, okay, it's saying that this is the average y value on that part of the function. And graphically, we can kind of see that. Since this is a nice straight line, negative 2 is smack dab right in the middle between 4 and negative 8. It's 6 units away from each of those. So it's right in the middle there. And since our interval is nice and evenly balanced, 0 to 6, half of the y values are above negative 2. So half are above y equals negative 2. And then the other half of the y values down here are below negative 2. So if we were to combine all the, well, really there's an infinite number of points along this part of the line, because you can, take points ever so close to each other. If you added together all the y values for this point, for the points that make up this section of the line, and you divided by that number of y values, you would end up with negative 2. Everything ends up balancing each other out at y equals -2. So that's the average value of our function there. Okay, so that's the idea of average value. Any questions looking at that? One little note for us. The reason why we were able to, why this turned out so nice graphically, how -2 was exactly in the middle of 4 and -8, was because that it was a line. If your function is more complicated, like something like that, you can't just take halfway between the high point and low point. That doesn't usually work. It's because this was a nice straight line. On this little wacky function that I just graphed, it looks like there's quite a few higher y values here, like going through this part of the graph. So your average might be skewed a little higher than what you might expect. Okay. But yeah, that's the idea.